Hello again everyone, this is Vincent and this is episode 11 of the Manufactoria walkthrough on Kongregate. And this will be the last episode because there's only one level left, and that level is Metatron. And again, it has over 100 parts. Alright, so in this level, again, like the Ophonym level, we have to read the string as the first set of reds and blues before the green in the middle is number A, and the second set of reds and blues after the green is number B. And what we have to do is we have to give an output which is equal to A plus B. Alright, so if you think back to the officers level where we had to add 1 to the binary string, remember that we could hit the problem where we had to carry to the next digit place if we got something like 1 plus 1, which gave us a 2, but you can't have 2 in binary. So I can start off with an example. Say we're trying to add the binary numbers 1010 and 1110. So how we do the addition is we line up the two numbers first of all, and normally we would work from right to left, because from the least significant to the most significant place, because that's the because when you carry, you go to the next most significant place. So just back to these numbers, so when we work from right to left, we first check the 2 to the power of 0 place. That's 0 plus 0. That's just 0. So 0 plus 0 just becomes 0. That goes into that digit place. The next digit place, in the next digit place, you have 1 plus 1. And remember, that will give us a 2, but that you can't have that in binary. So what we do is change that 2 to a 0, and then we carry a 1 to the next digit place, because that 2 becomes a 2 to the power of the next digit place. Alright, so now, in the next digit place, that is the 2 to the power of 2 place, we've got 0 plus 1. But remember, we had to carry from the previous digit place. So it's as if it's 1 plus 0 plus 1, because it's like, or 0 plus 1 plus 1 from the carry. So that's like 1 plus 1, which becomes 2 again. So we put a 0 there, and we do have to carry. And the next digit place is 1 plus 1, but we had to carry as well. So it's like 1 plus 1 plus 1. And that's 3, so that becomes 2 plus 1. So 1 goes down there, and another 1 goes to the next digit place, which just becomes a 1 because there's nothing else. So 1010 plus 1110 is equal to 11000. I hope that helped. I hope that kind of illustrated the kind of possible situations you can find when you're doing binary addition. So you could have 0 plus 1 or 1 plus 1 or 0 plus 0, and you could also have a carry from the previous digit place, depending on what that operation was. Alright, so what I do, so in my machine overall, before I get into the guts of it, is I have my first number, followed by the green, followed by my second number, followed by I put a yellow-green at the end of the string first. That yellow which I initially put there, I'm now going to label the carry symbol. And like in the Ophonym level, I can change this yellow from yellow to green and back from green to yellow whenever I need to. The second green just denotes the end of the second number. What I basically do in my machine is I compare the last two dots of number A and number B, or string 1 and string 2. And depending on the color of number A and the end of number A and end of number B and the carry symbol, I will put the carry symbol between the carry symbol and I will put some number between the carry symbol and the second green. And I may or may not change the color of the carry symbol as well. And I delete those last two digit places, and I delete those last two dots in the process. So that is essentially like me working from right to left in my binary addition. You have to work from right to left, not from left to right. Alright, so as I said before, I first put a yellow-green at the end. Then I go into this cycle, I copy what is now all of number A except for the last symbol. And that can either, where I see a color followed by green. So after I see that dot followed by green, I put the green back at the end. So now I've deleted the last symbol, but I've checked the color. Then I put a red at the begin. Then I put a red here. Now the reason why I put a red is because if string 2 is less than string 1, what could happen if I don't put a red is when I put the machine through, I just end up with a green or green yellow somewhere, and that's really nasty because it messes up the whole machine. So what I do by putting the red at the beginning of string 2 is that I ensure that string 2 is always greater than string 1, even if there's some reds before the number which don't do anything. So I put a red there beforehand, there or there, and then I go into this cycle where I check where I go into another cycle, and and again it's got a slightly modified structure to fit everything, where I copy the rest of string 2 except for the last symbol, where I check the color. Now, so that could be blue or red. Now, instead of just checking, now I don't necessarily know whether it's green or yellow, because remember, I said that the carry symbol can change from green to yellow at any time. So I check for the last color of string 2, followed by either green or yellow. Now, the reason why it's arranged like this, I'm going to bring up a table which just summarizes all the possible inputs of the end of number A, end of number B, and the carry symbol. And that is essentially all the different things that can happen, whether it's 0 plus had to carry or not to carry. 0, red or blue plus red or blue plus whether we had to carry or not. And so in this table, so if we just look at the first row, it's R, R, Y. The yellow I'm going to use to signify that we don't have to carry from the previous digit place, and green is going to be we carried something from the previous digit place. So blue is 1, red is 0, obviously, and green also acts as kind of like a 0. So in the first row, R, R, Y, it's like 0 plus we don't have to carry anything. That just gives us 0, and we don't have to carry anything at all. So it just stays as yellow. So if we plotted that, the path of that, it's number A ends with a red, number B ends with a red, and the carry symbol was yellow, so it goes up there. Then I put the carry symbol first, and in this case it's yellow, followed by the next digit place. So in that case it'll be red for RRY. Then normally I'll just see the second green on my first try, so it just follows a grey arrow, take off the green and put it back at the end. So in that case, I check the last two colors and then I put the last color at the end. And so if you look back, and if we look back at the table, you'll see why I have several of these parts routed along the same way, or it's routed to the same writers. So if, like, for BBG, the output is GB. So I first put the carry symbol as G, and then it routed as B. Now in the table, there are a few of them where string A the first string ends with the same symbol, and the output gives us the same carry and the same digit place symbol. So say BBY or BRG, they both route to green and then red, because they both equate to 1 plus 1. Or in these cases, the carry symbol is different, but the digit place is the same, so I just have these different carry symbols, so yellow or green respectively, but I route it to the same blue. So it just cuts down on the number of parts I need to use. Now, once I've done my first addition, because I've already put something between the carry symbol and the second green, I need to copy the rest of that before I take off the green and put it back on. So that's what this bit is for. Alright, so that's just how the addition bit works. It works on a logic statement involving 3 different inputs, and I have 2 different outputs that come after it. So eventually, once we're done, we should have a green followed by what's left of string 2, followed by the carry symbol, followed by the second green. And remember that the second string is always longer because I've been adding reds to the beginning of it before I copy it. So eventually we see a green where it goes down the grey arrow, and I rip it off. So now I see what's left of number 2, followed by the carry symbol, followed by the second green. So now I go into another or one of these cycles where I just copy the rest of where I have to check for the end of, where I copy and check for the end of what's left of number B. And I have to bring up another truth table because here we're only worried about the only inputs we're worried about are the state of the digit place and the state of the carry symbol, because we don't have a number A to work with anymore. So there are only 4 different outputs. 3 of them are terminals. So what that means is if you have a red followed by either green or yellow, if it's a red and green, I just turn that red into a blue, because when I carry into a red, it just becomes 1. That 0 turns into a 1. If it's R plus Y, it just stays as red. And so now when I rip those off, and then I replace those, the red with a blue or red respectively, and then I copy the rest of the stuff that happened before in number A, so the stuff that's after the carry symbol but before the second green, until I see my green, and then I rip it off. The last cycle we might need to go through is if the carry symbol is green, but we've also got a blue there. What happens there is I follow blue, green. I have to, again, put the carry symbol forward, because we have to carry, it's like 1 plus 1, and then I change that blue into a red, where I copy the rest of the addition, follow it until I see the second green, I rip it off, and then I go back here. So this is the last bit of recursion we need to do. I need to, once I've finished adding A plus B, I need to now check the status of the carry symbol and the rest of number A, or number B, sorry, until I get and see if I need to carry. If I do need to carry, I need to look for a red, which can resolve into a blue once with the carry. Alright, so first up, we don't need to carry because it's a blue plus a red, so it just becomes a yellow still. Now we need to carry, and now it goes down here, where that red gets resolved into a blue. And then copy the rest of the number, and then rip off the green. Alright, so that is the end of the Manufactoria walkthrough on Kongregate. I hope you found this educational, or I'm not sure if you could find it enjoyable, because it is an engineering game after all. And I hope you had fun, and I hope to see you in the whatever next walkthrough I do. So this is Vincent signing off on the Manufactoria walkthrough.